Hey folks, welcome to another VR video. Today we're checking out something interesting. This is called Atom Maker, and it's by a company called Abelana, and it's a virtual chemistry class, essentially. And I was terrible at chemistry in high school, so I figured I would check this out. We're going to check out the tutorial. It says the experience will help you gain a more intuitive understanding of the composition of atoms. Each atom consists of particles, such as protons, neutrons, and electrons. Use your panel to switch between them. Okay, so protons, neutrons, and electrons. So we'll shoot protons. There's a proton. And then you can suck it back out there. Okay. Alright. So let's say we want to make... they want us to make oxygen. Okay. So oxygen has an atomic number of 8. So we need to understand how many protons and neutrons we need. So the atomic number is 8. That means we need 8 protons? And for neutrons, we need the atomic weight, which is 15.99. And for some reason, the OK button is behind this tutorial menu, which is a little weird. So 16 minus 8 is 8 neutrons as well. And use the energy slider to go between the different energy levels called shells. Take the blue ball up to the 5th level of energy. Each energy level has different orbitals. So there is an S, P, D, and F. Go ahead and click any of the mini orbitals to select. So let's select this one. Now you know how to navigate the Atom Maker. Get onto the first energy level to start adding electrons. So, first energy level is an S orbital with 2 electrons, and then 2 electrons for second energy level, and 4 electrons for P. Okay. So we've got electrons. So we've got 1 and 2. Now go to the second energy level. We should have 2 as well, right? 2 electrons to the S orbital. Alright, now let's fill the P. So you select the P here, and then 2. Is that right? That looks right. So we need a second one. Okay, that seems right. 4 electrons into the orbitals. 1. Did I do that wrong? So let's take those back out. Let's try again. 1, 2. 1, 2. Nope. 1, 2, 3. So you need 4 electrons. Start by adding 1 per p orbital. Then 1 per p. It's not allowing me to do a second per p orbital. One. 2. 1. Nope. Alright, I'm not sure what to do here. for each p orbital, then add a second electron in the same order. So, got an orbital here and an orbital here. 1, 2. 1, 2. 1, 2. 1, 2. That's weird. So I'm not sure what to do here. We're going to exit the tutorial. And we're going to just try to build something. Let's see what happens. So I want to make zinc. Let's see how to do that. So we need 30 protons. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. That's 30 protons. You can see them right here. That's what we counted. So we're going to commit those. And then for neutrons, we have an atomic weight of 65. So we need 35 of these. Now we can commit that, and that's correct. So we've got the nucleus done. Now if we move up one, we've got an S here. And one S is 2. So we need 2 electrons. Now we need to move up to 2s. And we've got 2s and then 2p6. So we got 2s. And then this is where I don't know what to do. We've got 2, 1. And yeah, I don't know how to do the 6 here. Am I missing? I feel like I'm... Oh, there we go. That's how it works. Okay. Got 1 for each orbital, 1 for each orbital. Now we can move on to 3. And 3 is 2 for the S. Then P, we've got 1, 2, 3. 1, 2, 3. 1, 2, 3. Whoops. Oh, 2, 2, and 2. Got it. Okay. So that's 2, 2, and 2. And then we've got D. 10. 1, 2. 1, 2. 1, 2. 1, 2. 1, 2. So those are green. So how do I do the 4S though? For this one is the question. Maybe they start down here? No. So I don't know how to get the 4S right here. That's the tricky part. Maybe we need to go up here to get the 4S. There we go. There's the 4S. Beautiful. And then there's no 5. This is done. So if we commit to this, it should work. That's zinc right in front of us. I just made zinc. I eat zinc lozenges sometimes to feel better. Oh, look at the earth down there. That's cool. Awesome. So let's pick a different one here. Let's do carbon. Carbon should be a fairly easy one, right? So we need 6 protons. 1, 2, 3, 4, 5, 6. We got the hang of this now. So it's 12, so we're gonna need 6 neutrons as well. 1, 2, 3, 4, 5, 6. This is awesome. So if we go to electrons and we move up, we're gonna need 1s times 2. There's 2. We got 2s times 2. 2p times 2. And I feel like that's it. I feel like we might have too many, actually. Let's commit. Is it wrong? It is. It's totally wrong because we did too many p. Now let's try it. 2p times 2. So let's get rid of 1 here, add 1 here, and commit. That's it! We just made carbon. So if I was studying advanced placement chemistry in high school, I could learn the actual proton, neutron, and electron atomic structure of the periodic table. Right here, they would help me with that test. This is so cool. All right, let's do one more. Let's do radium. Radium's going to be a tough... Oh, wait. Let's not do radium because that is huge. Let's do helium. Helium should be pretty easy. We've got 2 protons. And it's total 4, so we're going to have 2 neutrons. And if we move up here, we have 1s times 2. And, seems about right. That's helium. Super light. We've got different environments we can play through, so instead of having the Earth here, we can have this grid instead. It looks like the planets are starting to orbit us on the grid. It's very cool. And then we can also have this grid here, which I think is going to be like some shooting stars, maybe? I don't know. Maybe it's just the galaxy around us. I'm not sure what this does either. Just lets us look at that, I guess. And then our hand here. I'm not sure what that does either. Maybe that lets us grab things. Can we pull this? Yeah. Toss that away if we wanted to. Alright, let's... You know what? Let's try groups instead. Or countries. We can pick different countries as well. This one? Really? So this one was... Astatine was created here in the United States. Or discovered maybe in the United States. Let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Keep going. We get to 85. This is very cool. And I like being able to use a tool like virtual reality to learn. Now, am I going to remember the composition of astatine myself? Probably not. But as you can see, we need 125 neutrons. Let's keep shooting them into the cell here. Charging up that atom. One more. Okay. And then let's move up. Wow, this is a tough one. So we've got 1s times 2. There's 2. 2s times 2. 2p times 6. So we've got 2 for each of these. Then we've got 3s times 2. P times 6. Then 3d times 10. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we've got 4 S times 2, 4 P times 6, 4 D times 10, 3, 4, 5, 6, 7, 8, 9, 10. And then we've got 4 F times 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then we will move up to 5. We have 5S times 2. 1, 2. 5 P times 6. 1, 2, 3, 4, 5, 6. 5 D times 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm assuming 5F. Ah, there is no 5F. Okay. So 6S times 2 and 6P times 5. 2, 4, and 5. And let's try it. I think that might be right. Yeah! That is very cool. So we are creating atoms. So I had a ton of fun with this experience. This one is available on the Rift platform. Obviously, you can play it using the Quest 2 with Link. Special thanks to Oculus and the Quest Ambassador program for giving me access to this title and this hardware. I will be back with more content soon. Until next time, get out there and enjoy some VR for yourself. And thanks for watching. Bye-bye now.